All right, welcome back. So we're going to talk today about solving quadratics equations. Remember, quadratics are in the form of ax squared plus bx plus c, and we've been factoring these for quite some time. And now what we're going to do is add on an equal to 0. So this means that we're going to go ahead and solve these. The general shape, remember the general shape of a quadratic is this parabolic shape. All right, so if I were to draw an xy axis real quick, a parabola would be something that, is kind of U-shaped and can either go up or down. What we're interested in is these places where it could go ahead and hit the x-axis. So when it's a parabola, it hits in two different places. The two matches are 2 here. We're expecting 2 solutions. Okay, and for the most part, you're always going to get some sort of 2 solutions. There are exceptions to this. We'll talk about those later. But what we're doing is we're trying to solve these. If they factor, we should be getting 2 solutions. They won't necessarily be different. Let's go ahead and look at these. Okay, so if we're solving this quadratic, we need to go ahead and use something called the zero factor theorem. All the zero factor theorem is if I have, let's say 3, and I multiply it by 0, I'm going to get 0. Okay? So anything multiplied by 0 gives you 0. And if I think of these two parentheses as 2 different binomials, that just means as long as one of those binomials is equal to 0, I go ahead and I have a solution. So anything multiplied by 0 is 0. We know this from doing our multiplication tables. Let's kind of see how it's going to work. Now I have 2 equations here. You could see their quadratics from the squareds. All right, and these ones are purposely not pre-factored. Okay. And what I want to do first is I want to go ahead and put these into their factors. Okay, so if I go ahead and factor the first one, this one just has a GCF. So I'm going to pull out an x, all right, and I'm left with 1x in the first, because I have a squared term, minus 2. And those are equal to 0. So what I want to do with the zero factor theorem is I want to take each piece of this puzzle and set it equal to 0, and I'm expecting 2 solutions. So either x is equal to 0, that's pretty much solved for me, x is equal to 0, or x minus 2 is equal to 0. And all this is I have to go ahead and do a little bit of solving. Okay, so if I go ahead and add 2 to both sides just like I would for any other equation, x is going to be equal to 2. And that makes sense because 2 minus 2 is 0. And as long as this is 0, then it doesn't matter what the other item is. It's going to be 0. All right. And this one, notice I only had an a. This was in the form of ax squared plus bx. Okay. So there was no c here, and it doesn't make a difference if it isn't or isn't. Is or isn't. Sorry, it's early. Let's go ahead and look at one that has both an a b, and a c part. Okay, I'm going to go ahead and quickly factor this. So this is x minus 3, x plus 1, and they're all equal to 0. All right, which means either my x minus 3 is equal to 0, which would make this piece 0, and 0 times anything is 0, and this makes it true, or x plus 1 is equal to 0. So I'm going to take each of these 2 small equations and I'm just going to solve them real quick. You may be able to do them in your head. That is totally okay. Add 3 to both sides. So x is equal to 3. And that makes sense. 3 minus 3 is equal to 0. Or x plus 1 is equal to 0. So we subtract 1. And so x is going to be equal to -1. So my solutions for the first one I did would be 0 or 2. My solutions for the second one with a C would be -1 and 3. Okay? And you could put an x equals out there, just makes it look a little nicer. And this is the whole idea we're going to work with. Now, you're not necessarily going to be factoring these first ones, so don't worry about it. We've already done our factoring. And let's go ahead and look at some examples real quick. All right. So this one, it's already pre-factored. I have x minus 4 and x plus 3 is equal to 0. So you're going to set each piece equal to 0. And solve each little piece. Okay, so the first one, I'm going to go ahead and add 4 to both sides. And I'm left with x is equal to 4. That makes sense. 4 minus 4 is 0. Notice I'm still checking these. And second one, x plus 3 is equal to 0. Let's subtract 3 from both sides. So x is equal to -3. So our solutions are 4 and -3. Okay. So I don't necessarily have to go ahead and write them in numerical order. It's also okay if you just leave x equal to 4 and x is equal to -3. That's totally acceptable. So you can kind of leave this out if you want to. And just keep those two right there. So as long as you solve both of them, have both pieces there, I could go ahead and see those. All right. I'm going to do a couple more here. So this one, I have 2x plus 3 times x minus 4 is equal to 0. Remember, just set each piece equal to 0. Okay. And then we're going to go ahead and solve. And you can solve either one in any order you want. Okay. So we have x minus 4 is equal to 0. That one's going to be easy. Add 4 to both sides. And we're done. X is equal to 4. 2x plus 3 is equal to 0. Remember, the first thing we got to do is get anything away from the x over first. So subtract 3 from both sides. And I'm left with 2x is equal to -3. And then I have to go ahead and divide by 2 to get the x by itself. And x is equal to -3 over 2. That's totally okay. There, you will get fractions when the number in front of our x is not 1. All right? And you don't have to do anything with it. These are just your solutions. You're not graphing them. You're not doing anything else. You're just getting 2 solutions. Okay. Let's go ahead and look at this example here. So I have 2x times 3x plus 4. So either 2x is equal to 0 or 3x plus 4 is equal to 0. All right. Now, the first one looks a little weird. It's like, well, how am I going to solve that? Remember, you can just strictly use the zero factor theorem. 2x is equal to 0. What times 2 is going to give you 0? 0. So x is going to be equal to 0. This is the same idea we talked about when we first introduced the zero factor theorem. Anything times 0 is 0. You didn't really have to do this. You could go through and divide by 2, but it's not going to change anything. 3x plus 4 is equal to 0. Oops, sorry. So subtract 4 from both sides. And I have 3x is equal to -4. We're expecting a fraction here. We'd go ahead and divide by 3. And x is equal to -4 over 3. And as long as you have the 2 pieces there, you are ready to go. And you can always put these in and test your answers. Let's go ahead and look at this one. Now, this particular problem is our difference of squares. So if I were to FOIL this, it would be x squared minus 25. Okay, just so you kind of know what it looks like, in case you've forgotten. All right, and I'm going to set each piece equal to 0. So either x plus 5 is equal to 0, where x minus 5 is equal to 0. Again, you could probably do this one in your head. Subtract 5 from this one, and I get x is equal to negative 5. And add 5 to this one. X is equal to positive 5. Okay, so again, we still have two solutions. This last one is it has an A and a C, but no B because they canceled out. Right? Let's look at one more type here. Now you can do this with higher order polynomials if they factor. All right? So I'm going to look at a cubic really quick. As long as you could set each piece equal to 0, it's still the same thing because the one I'm giving you is factored already, and I factored it. All right. So if I look at the general equation, y is equal to x cubed, and this may or may be something that you haven't seen. Okay. I haven't really talked about cubes. All right. The shape of a cubic is kind of like this S thing. And so this one particularly is centered at 0. So even though I have x cubed is equal to 0, x can only be one thing, which is 0. So you're saying, well, you're expecting I hopefully have 3 solutions here. But this particular graph is going ahead and only hitting one place. So it's a repeating 0. Still has 3 solutions, but they're all going to be exactly the same. If that makes sense. Because we have, at this point, we have a 3 here. We're expecting 3 solutions, but in this case, they're not unique. All right. What we're interested in if I give you something that looks like the last example here, okay? And I have 3 different pieces. This is a cubic that's factored. I'm not expecting you to be able to get it into this form. I just want you to set each piece equal to 0. So either x is equal to 0, x minus 3 is equal to 0, or x plus 4 is equal to 0. Okay? So our first one's already solved for us. The next one, I add 3 to both sides. X is equal to 3. And the last one, I subtract 4 from both sides. X is equal to negative 4. All right. And all this means now is this cubic graph is just going to do a variation of what I drew up top. It means it's going to go ahead at negative 4. Come back, hit 0, and come, nope, I don't know what this thing is doing. Let's not do that. It's going to come up, come down at 0, and come back up. Okay, so it's doing a variation on a theme, but it looks a little weird. And it may or not go that low or that high, but that's kind of the idea. So go ahead and work out the problems we had today, and I will see you in the next video.